So number 7 says, right, velocity vector 40 degrees above the positive x-axis has a y component of 10 meters per second. What is the value of the x component? Oh boy. All right, so let's start by just drawing it. All right, we have let's give sometimes just having a coordinate plane makes life a little easier. Okay. I wish there was I wonder if there is. If there's something where I can just drop in a coordinate plane. XY. That was an XY origin, but no Alright. So let's go back to our XY coordinate plane. And we have start with a velocity vector that is 40 degrees above the x-axis. So it's something that looks like this. And we'll call it V. And we know that they've told us that the velocity vector, the y component I should say, v sub y is equal to 10 meters per second. And that's what we've got there. So we know, all we know is the angle and we know the y component. Okay? And they would like us to find out the x component. So they want to know what is v sub x. Okay? So we know that if we want to find v sub x, we know that we need v cosine theta, correct? That's what's going to help us, v cosine theta. Okay? All right. But we don't know v. We don't know v, right? That's a bit of a problem. So that's the first thing we got to do. If we're going to find v sub x, we need to find v because we know what theta is. Luckily, we know v sub y. We know v sub y is equal to v sine theta. And we know that v sub y is 10. V sine theta. So v is then 10 divided by the sine. So we do 10 sine 40, 10 divided by the sine of 40. What do you get? Ooh, the mad dash to take out the calculators.
If we want to, can we use the law of sines if you want us to do it that way?
It doesn't matter.
Okay.
Honestly, you can use the law of sines if you want. Long run, this not going to get a whole lot of problems. You're really not going to get any problems like this on the test. Right now, what we're doing is we're building the foundation for projectile motion. So, go nuts. But knowing how to use the components is very important for later on. Okay? So 10 divided by the sine of 40 is, Jared? 14 let's call it 6. 15.6? Yeah. So 15.6 meters per second. So now we can shove that right up in here. Times the cosine of 40. So 15.6 times the cosine of 40 will give us the x component of 11.9. 11.9, don't forget meters per second. And there we go. Okay? When it comes to dealing with vectors and components, the best thing you can do right now is draw like these little pictures, right? Because it'll help you visualize what's going on, and it'll make life a little bit easier in terms of then figuring out how to solve these. Okay? What do you think? Pretty good? Not too shabby? All right.